Welcome back to Codeverse, where we break down complex programming concepts into simple, actionable lessons. Today, we're stepping into a cornerstone of object-oriented programming, something that powers everything from game engines to enterprise software. It's called inheritance, and no, it's not about money or family trees. We're talking about reusing code, modeling real-world relationships, and making your C++ program smarter and cleaner. Imagine you're building a program with multiple types of vehicles, animals, employees, and they all share common features. Would you rewrite the same code for each one? Of course not. That's where inheritance comes in, allowing you to define common logic once, then build specialized versions on top of it. In this video, you'll learn how inheritance works in C++, the difference between base and derived classes, what access specifiers do in inheritance, how to override methods and extend functionality. Plus, we'll dive into a real coding demo, test your understanding with a quiz, and give you a final challenge to lock in the knowledge. Whether you're new to OOP or just brushing up, this lesson will give you a rock-solid foundation. So, open your editor, grab your favorite beverage, and let's explore inheritance in C++, the smart way to write less code and do more. Alright, so what exactly is inheritance in C++? Let's simplify it. Inheritance is a feature in object-oriented programming that lets you build a new class based on an existing one. Think of it like this: imagine you have a general class called vehicle. It has properties like speed, fuel, and color, and maybe a method like start or stop. Now, you want to make more specific types of vehicles, like car, bike, or truck. They all share those basic features, right? Instead of rewriting that code over and over again, we just inherit it. That means the new classes, called derived classes, automatically get all the properties and behaviors of the original base class. It's like giving the child class a starter kit of code, and then letting you add or modify whatever you want on top of that. This makes your programs shorter, cleaner, and much easier to manage. It also helps you model real-world relationships naturally in code, because a car is a vehicle, just like a dog is an animal. So in C++, inheritance is your way of saying, hey, I've already defined this logic in one place, let's not repeat it, let's reuse and extend it. That's the essence of inheritance: reusability, extensibility, and smart design. Now that we know what inheritance is, let's talk about why it's such a big deal in C++. Why should you bother using it in your programs? Well, inheritance isn't just a fancy feature, it solves real problems and makes your code smarter, faster to write, and easier to manage. Let's break down the key benefits. First, code reusability. With inheritance, you define common behavior once in a base class and reuse it across multiple derived classes. No more duplicating functions or variables. Change it once, and it updates everywhere. That's a massive time saver and reduces bugs caused by inconsistency. Second, cleaner, modular design. Inheritance helps you break down complex systems into logical, layered components. Each class has a clear role, and shared logic is centralized, not scattered. Third, real-world modeling. Inheritance lets you describe relationships like, a manager is an employee. A dog is an animal. A sedan is a vehicle. This makes your code more intuitive and easier to read for other developers, and even for your future self. Fourth, maintainability. If you want to improve or fix a shared method, you can update it in the base class. All the derived classes automatically benefit, without touching their code. And finally, extensibility. You can add new specialized classes without rewriting the existing base. It's flexible and scalable, perfect for growing projects. So, inheritance isn't just a technical trick, it's a way of writing code that's logical, dry, don't repeat yourself, and built to last. Now let's see how inheritance actually works in C++ using two powerful concepts: base classes and derived classes. A base class is the general blueprint. It holds the common properties and behaviors that multiple classes can share. For example, we can create a class called animal. This class might include methods like make sound, sleep, and eat. All animals share these behaviors, so it makes sense to group them here. Then comes the derived class, a more specific version of the base. Let's say we create a dog class that inherits from animal. Now the dog automatically has access to all the animal features, no copy-paste needed. But it can also have its own special features, like bark. You can think of the base class as the parent, and the derived class as the child. The child gets all the traits of the parent, but can also grow in its own way. In C++, inheritance is declared like this: class dog, public animal. The keyword public here means that the public members of the base class will stay public in the derived class. There are other inheritance types, like private and protected, which we'll see later. But here's the magic: once you build your base class well, you can create many child classes from it, each one unique but still connected. This structure makes your code organized, scalable, and easy to update. Change the base class once, and every derived class automatically benefits. In C++, inheritance isn't just about extending functionality, it's also about controlling access to inherited members. That's where access specifiers come in. There are three main access specifiers: public, protected, and private. Each one determines how the members of the base class are inherited by the derived class, and how accessible they are. Let's start with public. If a base class member is public, and it's inherited publicly, it remains public in the derived class. This means the derived class, and other code, can freely access it. With protected, things get a bit more controlled. A protected member is like a private member, but with one key difference: it's still accessible within derived classes. It stays hidden from outside the class hierarchy, but accessible to any subclass. Finally, we have private. A private member is completely hidden, even from derived classes. It's strictly for use within the base class itself. The child class won't be able to access it at all. Now here's something subtle but powerful: the mode of inheritance also affects access. For example, if you inherit a base class privately, even its public members become private in the derived class. It's like setting boundaries. You're not just reusing code, you're defining how much of that code should be exposed or hidden. This gives C++ powerful tools to model real-world relationships, like has a, or is a, with just the right level of control. Now let's get practical. How do we actually write inheritance in C++? The syntax is quite simple but super important to understand. When you define a derived class, you use a colon, followed by the access specifier and the base class name. For example, class animal, class dog, public animal. This line class dog, public animal means that dog inherits publicly from animal. That's where the inheritance magic begins. You can also use private or protected instead of public, and that changes how the inherited members are accessed. We'll explore that in the next part. Also, keep in mind, the base class must be defined before the derived class uses it. Otherwise, the compiler won't know what you're trying to inherit from. The base class can be empty or fully defined. As long as it's declared, inheritance can work. You can even inherit from multiple classes by separating them with commas, like class child, public parent 1, public parent 2. Though multiple inheritance is advanced, C++ does support it. For now, focus on the basic form. It's the foundation of everything you'll build using OOP in C++. When a class inherits from another, it doesn't just take everything and freeze it. It also has the power to customize how things work. This is where overriding comes in. Overriding means we redefine a method in the derived class that already exists in the base class. This lets the derived class change the behavior while keeping the same name and signature. Think of it like replacing an old engine with a better one. It still fits, but now runs differently. In C++, to override a function, we simply redefine it inside the derived class using the same name, return type, and parameters. Optionally, we can add the keyword override to signal our intent clearly. Example, if the animal class has a function makeSound, and the dog class inherits from animal, we can override makeSound inside dog to bark instead of making a generic animal sound. But that's not all, we can also extend the behavior. That means using the base class version, and then adding more functionality before or after it. In C++, you can do this using the scope resolution operator like this: animal, makeSound, call the base version. Then follow it with extra behavior specific to the derived class. Overriding and extending are the cornerstones of polymorphism, one of the most powerful concepts in object-oriented programming. Mastering this lets you build flexible systems where derived classes can act differently, while still playing by the same rules. Let's bring everything we've learned into action with a live coding example. Problem: we're building a simple game, and we have a base class called character with a method attack. Now, different types of characters should attack differently. For example, a warrior should use a sword, while a mage should cast a spell. But both share the same interface, they must have an attack method. So how can we make each one behave uniquely while still using the same method name? Here's where overriding comes to the rescue. We'll override the attack method inside each derived class to give it custom behavior, and even call the base version to extend the functionality if needed. Let's code it. Include iostream. Using namespace std, class character. Public, virtual void attack. Cout character attacks in a basic way. Endl, class warrior, public character. Public, void attack, override. Cout warrior slashes with a sword. Endl, class mage, public character. Public, void attack, override. Cout mage casts a fireball. Endl, int main. Character C1 equals new warrior, character C2 equals new mage, C1 dash attack outputs, warrior slashes with a sword. C2 dash attack outputs, mage casts a fireball. Delete C1, delete C2, return 0. What just happened? We created a base class character with a virtual method attack. Then we overrode that method in warrior and mage classes to change its behavior. In main, we used base class pointers to call attack, and thanks to polymorphism, the correct version was executed at runtime. This is the power of overriding, it lets you write flexible, reusable, and extensible code. Let's quickly test your understanding with a mini quiz. Question 1, you have a base class animal with a virtual function makeSound. You also have a derived class dog that overrides makeSound, to bark. If you call makeSound, using a pointer of type animal pointing to a dog object, what sound will be made? A. Generic animal sound. B. Bark. C. Compilation error. D. No output. Answer, B. Bark. Since makeSound is virtual and overridden in dog, calling it through a base class pointer will invoke the derived version. That's polymorphism in action. Question 2, what happens if the base class method is not marked virtual, and you call it using a base class pointer pointing to a derived class object? A. It calls the derived class method. B. It calls the base class method. C. It causes a crash. D. It depends on the compiler. Answer, B. It calls the base class method. Without virtual, C++ uses early binding, and the base class method is called even if the object is of derived type. Question 3, what's the correct keyword to force overriding and catch accidental mistakes when overriding? A. Overwrite. B. Override. C. Virtual. D. Final. Answer, B. Override. It tells the compiler you're intentionally overriding a virtual method. If the signature doesn't match, the compiler gives you an error, super helpful. Great job if you got them right. If not, don't worry, just rewind and rewatch the example section. Mastering overriding takes a little practice, but it's absolutely worth it. Alright, here's your final challenge to test what you've learned about inheritance and polymorphism in C++. Imagine this scenario: you're building a simple zoo management system. You have a base class called animal, which has a method makeSound. Then, you create 3 derived classes: lion, elephant, and monkey. Each of these classes overrides the makeSound method to print a unique sound: roar for lion, trumpet for elephant, and oo-ah-ah for monkey. You also have an array of pointers of type animal, and each element points to one of the derived class objects. Your task: use a loop to iterate over this array and call the makeSound method on each object. What will happen if the makeSound function is marked as virtual in the animal class? And what if it's not marked as virtual? Try implementing both versions, with and without the virtual keyword, and observe the difference in behavior. This challenge is all about seeing polymorphism in action. If everything's set up correctly, each animal should make its own sound. Give it a try, and once you're confident, move on to the next lesson. Nice work! Today, you've just unlocked one of the core superpowers of object-oriented programming: inheritance in C++. We saw how a child class can reuse, extend, or even override behaviors from a parent class. That means less code duplication, better organization, and way more flexibility in your designs. From base classes to derived classes, and even to virtual functions and polymorphism, you now know how to make your code smarter and more modular. And don't forget, C++ allows multiple levels and even multiple inheritance, so the design possibilities are massive. We'll explore those advanced forms later. But up next, we're going one step deeper into how real programs store and retrieve data over time. In the next video, we're diving into file handling in C++. You'll learn how to read from a file, write to a file, check for file errors, and safely manage file resources. That's how your programs become real-world ready, by interacting with data outside the console. So make sure to like, subscribe, and turn on notifications so you don't miss that. This was Codeverse. Keep coding. Keep exploring. See you in the next one.